Hello everyone and welcome to Ocean Cadence. Today we will be taking the topic of multi-stage air compressor in this video. So let us see how it works. The first question that is but natural to arise is, what is a multi-stage compression system? So as we know that compressed air is used in different verticals on board a ship, that is from starting of an engine to the control air system and starting of auxiliaries, safety mechanisms and a lot of places. So the topmost pressure that we have to attain in a compressed air system on board our ship is, theoretically speaking, is 30 bar. Now to achieve this 30 bar compressed air, we use air compressors. So as we know that we take in the atmospheric air, that is air at atmospheric pressure is taken in into the compressor and then compressed further. Now by our imagination itself we can analyze that to compress the atmospheric air up to 30 bar, we can understand how much big of an aperture of compressor will be required to reach that value. But since we have space limitations, the power limitations for the motor and as well as the cooling limitations, hence using that bigger compressor is design wise and theoretically both and practically as well not possible. So then what do we do? In order to compress this atmospheric air up to a value of theoretical value of 30 bar, we use multi-stage compression systems. That is, a compressor would have multiple stages. It can be a tandem air compressor design, or it can be inline cylinder design, it can be W type design where two or more cylinders are used. In my example, I am showing you a typical two cylinder arrangement. It can be, you can analyze it as a tandem or as an inline one as well. So what happens is that instead of compressing the air in a single cylinder, multiple cylinders are used, that is multiple stages are used. So as you can see that air at pressure P1, let us assume that atmospheric pressure is P1. So we draw this air into the first unit which has a dia of D1, that is the cylinder dia, and then this air is compressed and brought to pressure P2. Then after P2 this air is sent, that is this is the this P2 is the maximum compressible value that can be obtained with the design limitations of this cylinder, and then this air is sent into the next unit, that is the one with the dia D2, and then this P2, the air which is at pressure P2 is compressed until the value of pressure P3, which is ideally the pressure that at which we have to obtain the air and use it for our different operations. So in this it is very clear that the pressure obtained P3 is greater than P2, which is inlet pressure of the second cylinder, and the P2 is greater than the inlet pressure of P1, which is the inlet into the first cylinder. Now as we know that density is inversely proportional to volume, so we also know that the more we compress the air, the volume would decrease but density would increase. So if the volume that which we are handling is decreasing, so let us say that volume at the stage over here in the first cylinder will become V1. Now if the stage, that is the second cylinder, if we use the same dia of cylinder, then we are allow, or a larger dia or a same dia, then we are allowing during the suction stroke for the air to expand again one, but that is of our loss because then we are allowing the air to expand again and then we are going to compress it again. So we will not be reaching the ideal value that we need. So in that case what we do is that the second cylinder, that is made with the inline or the tandem one, would always have a smaller dia, that is a smaller cross section of the cylinder, so that the air which enters after compression from the first unit into the second one is not allowed to re-expand that much and it can be further compressed, and then as we can see it is raised to the pressure P3. That is what we have mentioned here, that the size of the subsequent cylinder will always be less than the size of the preceding cylinder. Moving on to the next topic. So, as we know that when we compress air or any compressible fluid by the gas relation, that is the ideal gas equation, PV is equals to MRT, pressure is directly proportional to temperature. That is, the further we raise the pressure, the higher will be the temperature. What happens by this is, as the molecules of air, they gain more and more heat to raise the temperature because of the compression. The molecules, they drift apart. When they drift apart because of gaining this energy in an excited state, then what happens is the uh, volume of the gas, that is the volume of the space that the gas occupies, is more. This means by density is equals to mass upon volume relation, the density will become lesser and lesser. But ideally we need air in our compression system, that is the starting air system and everywhere, to be more dense and occupy lesser volume. That is how we get better quality of air. So that is what the first point focuses upon. The use of intercooler reduces the volume of air between stages, thereby increasing density. What the intercooler does is, as you can see, from the first to second stage, when the volume is taken in after second to third stage, when the compression occurs, when we use intercooler, it takes the point from 3 to 5. Between going this from 3 to 5, what happens is the volume of the air is becoming less, and then we go further into compression into the second stage. Also the intercooler reduces the temperature of air under compression, thereby saving wear and tear and preventing damage of easy handling. What it means is that the more amount of heat that the air would pick up during compression in between stages, the more difficult it is for us to handle this air into the system, and also further to store it into the system. So by removing this unnecessary heat that is gained during the compression process, we are making it easier to handle, store and work with this air, and also preventing the damage and wear and tear that can occur into the compression system, as well as the storage system, that is the air bottles or anywhere. That is, the final one is done by the aftercooler. As you can also see that by doing this multi-stage compression along with intercooling, we are bringing the graph in this, that is the PV graph, we are bringing it as close to isothermal compression as possible. That is the theoretical value that we want to achieve by compressing the air during the compression system, that is achieved by the use of intercooler and multi-stage compression system. How? As you can see that when we are moving from the point 2 to point 3, by intercooling we are bringing it to 0.5. Then further, when we are compressing it in the second stage, it is going to 0.6 dash. So what we do is that the work that had to be done extra if we were using a single stage compressor system, or if intercooler was not there, between the points 5, 6 and 3, this amount of work is being saved in every compression cycle. So we are achieving better efficiency and better isothermal conditions during the compression of the air. This results in significant saving of the amount of work that has to be put in, as I have written here, and further compresses the air and also conserves the energy. Moving on to the next slide. So this is the typical cooling arrangement that is being used. Most of the ships, they use freshwater system, because the freshwater system will not give any problem regarding scale formation or anything, and it gives a higher amount of running of cooler life. So what happens is that when the air is compressed from the value P1 to P2 within the first stage of the compression system, after that this air is passed through the intercooler, and over here the cooling water inlet and outlet is shown. So this cooling water picks up the heat, and this amount of heat is removed from the air, and then this air enters into the second stage of the compression system. The both supplies, they can be individual, that is both of them can be the discharge of both the lines from both the coolers can be going into a common discharge line, or there can also be a system where the discharge from the first stage, that is the intercooler stage, a part of it or complete part of it can be used into the inlet side of the after cooler to further pick up the heat and to gain better efficiency out of the cooling water system, and then this water can be further circulated into the cooling water line return side. This cooling water within the cooling water circuit will then be led to the auxiliary seawater coolers, where it dispenses the heat that has been accumulated from the source, that is the compressed air, and again comes back into closed loop circulation. The only top up would be done by the expansion tank or the auxiliary cooling seawater cooling freshwater circulation system that is available on board. So I hope this clears all your doubts regarding multiple stage compression system, and if any, please do feel free and do feel open to comment into the comment section and let us know your doubts, or if anywhere any improvements are required. Also, I request you to kindly like, share and subscribe our channel and our videos, and please refer anyone in need of the relevant material and encourage us to keep creating more and more such content. Thank you.